All right, this is the last speech before our coffee break, and so let's welcome our speaker, PALEJS.
Yeah, hello everyone. My name is PALEJS, company Clusterpoint. And what I'm going to talk today is about network traffic surveillance, network traffic recording, and most importantly about both challenges and the benefits such solution does bring to the customer using such thing. Of course, I'll base this description and talk on the product that we've been developing that does just that, captures and provides insight into the readable network traffic in your network or internet, up to you really. So let's move on. What we've created, is a system that gives and provides fast and almost real-time access to all the online interactions in the given network, be it your company network, specific department, specific area, or your connection to the internet itself. We monitor this and record and focus on the contents of this traffic. So how it's done? Basically, it's an appliance or a cluster of appliances that does a number of things in parallel. For one, it records network traffic, the same TCP UDP traffic, re-engineers it back to application level. So from the connections that we capture and that we store, we recreate web pages people have been viewing, emails people have been sending, receiving, audio, video information, documents, as well as various more technical aspects like DNS requests, etc. Pretty much everything that's not directly encrypted and is readable and recognizable. And and talking about analyzing, we go into the files and documents themselves as well. System recognizes things like Microsoft Office documents, Word, Excel, PowerPoint, PDF files if they are in a readable form, and indexes and recognizes their contents as well. Next thing that the system does is store this traffic. Since the system is linearly scalable, we can store this traffic for, well, as long as it takes. Usually it's months, 6, 9, but could be years just as well. We just scale up the system itself for more storage and computing power. Within the system, within the collected data, pretty much everything is indexed. All the bits of pieces that we capture, starting from contents of web pages, documents, emails, down to users, user information, IP addresses, timestamps, MAC addresses, statuses, protocols, whatever we can capture from and understand from the traffic, we index, and therefore we make it searchable. And thanks to our own Clusterpoint developed NoSQL database solution that we are using in the core of this solution, we are able to provide basically sub-second searches even in very large amounts of collected data, as of course the amount of data grows as you collect more and more traffic, especially if it's a larger network, but I'll get into that a bit later. In practice, what it means is that under normal circumstances, the system works the way that after the traffic has passed your network, we've caught it, we've monitored it, it takes about 5 to 10 seconds for this information to be recognized, analyzed, indexed, and inserted into the database. So 10 seconds after somebody receives an email with an Word attachment, you can find this email based on some keywords within the Word document itself, for example. Therefore, you can find who sent it, to whom he sent it, etc. What it gives altogether is a system that allows us to do a number of things, and this is actually one of the most kind of challenging to describe parts, because different users, our customers use the system in various ways. But basically, the ability, the things that the system provides is ability to monitor suspicious behaviors. People usually tell me that whatever network they are running or managing, there's always somebody or someone that is better be monitored more or less closely because of, various assumptions and stuff. Another thing is, of course, the system allows you to build automated alerts on even very specific events, starting from, of course, the very general things, increases in email traffic or something like that, down to very specific cases where you can define an alert to be made once a document with the specific metadata or meta tags is being sent out to the network, as some of our customers are doing it. And last but not least, the system basically becomes kind of a tool to turn to once you have to investigate suspicions, incidents, anything that you would like to take a second look at in your network traffic, network contents. Usually to have kind of an outside reference and comparison, I usually compare the system to your regular video surveillance that almost everybody uses nowadays still, even though there are many other modern security solutions in the physical world. Bad things happen. Things get hacked, broken in, things get stolen, and what do? You turn back to your video recordings. You sit down, you turn back the time and try to see and understand in detail what was going on, why the breach happened, what happened before that, what happened during the attack, what happened later on. Clusterpoint, this Clusterpoint solution does exactly the same thing on the IT level. We are basically a passive solution that monitors traffic on the network. More technical note, the traffic is monitored usually whatever way we can do it. Usually it's monitoring or mirror port somewhere in the network equipment that copies part of your traffic into the appliance to monitor, record, and analyze. It could be network taps sitting on some network connections, or the system can simply sit as a transparent bridge somewhere in line, letting traffic through and recording it on the way. And as such, of course, it sees everything on the network independent of operating systems, etc. As long as there is something in your network that's transmitting and receiving traffic over the network, no matter whether it's a phone, computer, or a smart fridge, the traffic gets recorded, and you can look it up later and do your investigation. Now for the challenges and questions and benefits. I'll start with since the questions will hopefully come at the end, I'll start with some of the most common questions that people are asking about solutions like this. What do you mean by capturing all traffic? Well, we do just that. We allow users to capture all the traffic. Then again, we do have our recommendations, of course, on how to do it and how to minimize the traffic that you need to collect. Namely, for example, we strongly advise to capture TCP traffic and leave the UDP traffic mostly alone, because UDP is a very technical still protocol and layer, and most of the traffic in there is technical and unreadable. Since we are focusing on the readable traffic, it's the TCP. For UDP, you can listen to specific ports, for example, for DNS requests and such, so you have a picture of that within your system. That being said, and some other methods employed, like the duplication of data once in a larger organization, let's say a bunch of users going to the same news sites and online resources every morning, we can cut down the traffic that we need to save to fairly manageable amounts. So, of course, depends on a customer per customer basis, but to have some indication, like in here, a fairly large company here in Latvia, for example, they're monitoring about 1,500 hosts within their network with a system like this. Our system in this configuration goes through about 1.5 up to 2 terabytes of data per day. And all this results in about 80 to 100 gigabytes of data that the system saves per day. So that's the readable contents, the metadata about the traffic that their customers generate. As I said, of course, you can adjust those numbers quite by large amount by choosing what exactly out of all the traffic you monitor. The same goes for, since we collect as well audio-video information, it makes sense to go through the configuration of the system after a while and, for example, disable or whitelist specific computers or hosts on the network. For example, servers, update servers that are just running updates, downloading them all day long and probably not causing too much potential damage to your network. You can, well, just exclude this from the monitoring. The same goes for some, for example, most popular audio video streaming sites, which even in large organizations nowadays, a large part of traffic consists of audio, video, people listening to, I don't know, Spotify, online radios and stuff for in their background. That all accounts for gigabytes and gigabytes of data that we can just skip and focus on the necessary stuff. Another question about the encrypted traffic. And of course, as techno-magical as we are, we do not decrypt encrypted traffic. So what we do what we can do, meaning we record metadata on the encrypted connections. We still see who was connecting where, at what time, how much data was transferred, and you can probably compare the how much of the total traffic for that customer, for that user, is encrypted against the whole traffic that he is generating. But that's pretty much it. Within the system, we can and do employ sometimes SSL proxy solution module, which then by inserting your own certificates into some closed part of the network, you can basically, as a man in the middle, intercept their encrypted traffic and do monitoring on that. Of course, that involves having access to the computers. That should involve, of course, warning the users of the computers, which usually is done, that their actions will be monitored. And that involves, of course, some sensible thinking about what HTTPS sessions you want to monitor. For example, of course, omitting internet banking, etc., but focusing on things like Gmail, which used to be fairly readable and nowadays is encrypted. But with a solution like this for some closed network, for example, a call center within a large organization where there are students coming in doing 8-hour shifts answering phones and using their computers. In there you can employ something like this to, with their permission, to monitor their communications, for example, if Gmail is involved within organization infrastructure or anything. Another issue, of course, with the encrypted traffic is secure and safe data transfers against having idea of what's in there. A typical example was one of our customers who are using Microsoft Exchange within their organization, and of course, as they should be, they are encrypted everything they can encrypt, including sessions between customers and their local Exchange server. And of course, the first complaint was, well, what's the use of the system if we can't see any of the email traffic in here? And well, the answer was quite simple. Either you are safe and happy that your transfers are secure, and you have no idea what's going in there, what kind of information is transferred, etc. Even though newest Exchange servers have fairly good tools to monitor things like that as well. And the another option is, at least temporarily, for monitoring or basically monitoring reasons, temporarily disable this encryption to have the ability to monitor what's going on in the email exchange, and live with that, and then of course re-enable it back, etc. Because one of the approaches for such monitoring of local traffic is not to monitor the whole organization, but to install smaller installations like this across the organization and rotate monitoring over several parts of the network on several departments. So basically, instead of recording everything, you do kind of a surveillance and pick network by network just to see that everything is fine and running as you would be expecting it. From here, I'll go into most probably interesting part, namely the use cases and the scenarios, how a solution like this is used, and what are, once again, the main challenges in those cases. First of all, where we see our solution in parallel with other solutions that, of course, everybody has within their networks to a certain extent already, is that, once again, the same as the video surveillance cameras, we really don't care about different assumptions, predefined assumptions. We, regardless of what usually the other security systems work on, either some policies or they learn the traffic anomalies, etc. We work straight, meaning we simply record everything, presuming that most of this traffic, of course, is safe and legal and you will never look into it. Still, we record everything so that we have this, and at later stage we can look back and say this, because the fact is you can never know, despite all your policies and everything, when something at present is wrong. I mean, somebody might be working now on the network, doing his business, sending his files and documents and reading and commenting stuff, and everything is fine because he is not breaking any policies. And then a month later it could be that there was some kind of a data breach or mess with the information sent with the customer documents, document versions, and all of a sudden it becomes very important what exactly was done this 1 week or 1 month ago within your network, what information was sent out, what information was read, what comments were done on the network. So this system and recording of traffic in general like this allows you to do just that, presuming hardware can manage it. For the use cases, surprisingly, to be honest, almost every installation, every case that we have with the systems like this comes with its own use of the system, which ranges from very common to very interesting ones. Of course, the most common one where the system is used is to basically monitor that the network is doing and performing the way that you think it's doing and performing, that users are not going where they're not supposed to, that emails and etc. are going the way you think they are. A good example of this is we installed a demo of this solution for a fairly large communication company, and as I said, the system works almost in real time. Once you switch it on, you feed traffic into it. 1 minute later, you already have several results captured from the network traffic, and you can look at them, analyze, and see who's been doing it, etc. So we installed this demo, and I said, well, let's just look into it. So before I'm leaving, so I'm sure that it's capturing traffic that you're happy and I'm happy. And we open up the user interface, look into the web traffic, and I said, yeah, well, it's working. There are 2 connections here already. One goes apparently to some of your local web resources. You see that by local IP addresses and stuff. And the other one goes to Draugi MLV. To those who don't know, it's a local version of Facebook, if you may say so, social media. Their network administrator straight away says, oh, well, yeah, the system is not really working because we've disabled all traffic to Draugi long ago, except for a couple of people in the company out of performance issues and stuff. I said, well, sorry to say, but if it's here, then it's been in the traffic. If it's been in the traffic and we've been capturing it, then I'll probably within half a minute can tell you, first of all, who was connecting to this drug MLW, how he did it, and I'll probably show you his face, because the first thing that he opens on his browser is his profile with his picture. And since our system can recreate and replay any of the recorded actions from the collected data, it's can easily be done and seen on the screen. And yes, of course, it turns out that well, the systems were working as expected, everything is fine. But well, human error, they forgot to close a specific way of connecting to a network. Namely, it was probably the physical IP addresses. They closed all the proxies in Lithuania and Latvia. They forgot to close the IP address access to the systems. Well, just one of the ways to look at it. Another thing, with another example from the from real cases, long-standing security threats. Nowadays, people are, even not the non-IT specialists, are getting smarter and smarter, and they know that they cannot bang into some systems they're not supposed to go into repeatedly, because they'll be probably disconnected, alarms will be raised, questions will be asked, a mess. So people are getting smarter, and in one of the installations, story goes that the guy was trying to connect to a financial database and doing it the right way. He was trying it once or twice a day, once in the first half of the day, once in the second half of the day. You need patience for that, but the system works. Single errors, they don't really raise any alerts or anything. At the same time, if you have suspicions and you look at those data on prolonged periods of time, you see that over period of 3 or 4 months, the guy had over 100 attempts on connecting to the database, and no one really knew about it. At the same time, I have to tell, of course, there is no magic in this or analyzed like this. So there are no red lights in the system that lights up once somebody is breaking into the system in a 3-month period. You have to have some suspicions. The point is that this is, and such total traffic recording is a tool that can be used once you have those suspicions to prove you wrong or prove you right, and go and do certain things about it, either talk to the users or improve your own security, your own network, etc. The same goes of course, since the system records both the internet traffic, including email, can be used to monitor email and internet use or abuse. What else? As I mentioned already, system allows us to specify and run very specific alerts on certain things within the traffic. Like example here, you can have a very specific alert defined on specific keywords in the documents that being sent out and in of the organization, and administrator will be alarmed of something like this. Once again, it all comes to the ways companies use this, because we've had companies saying, well, we don't really care at all, you can disable it. Who goes where? Facebooks, news sites, etc. We don't care. Only thing we care about is that no documents with such and such criteria or such and such parameters like document drafts go out of the organization, because that's about the only way they can be smuggled outside the network, and we would like to do the best to avoid that. Of course, as I said before, encrypted traffic and all that is still there, and there are probably hundreds of ways you can avoid being detected by a traffic recording system like this. But then again, if something goes unencrypted, we can capture it. So once again, another example, and it's a kind of more of a local as well, but the information protection laws here in Latvia forbid, for example, transfer of personal information, personal data over the public network unencrypted. So once again, we've done a module within our system that does just that, analyzes the web traffic, documents, emails for presence of personal codes within this data. They can be checked against the formula for patterns, etc. And so as long as it's encrypted, we don't care, we don't see that, and everything is fine and compliance is in place. As soon as we notice people's personal codes somewhere in organizations, local or external traffic, alarms can be raised, actions can be taken to prevent such thing and get back into proper use of the information channels. One of the last slides probably. Aside from traffic content, etc., we still, of course, capture all the metadata, etc. And being traffic and platform independent, system can easily draw up pictures like this, showing structure of your network based on the real traffic that's been going on per day or per week or per month. And this traffic and these charts like this as well can basically at glance show you where what are the main, not the main, all the traffic streams within your network. If you're interested in this, you can filter them by protocol. And once again, improves overall network security and helps you with detecting some potential connections to your network that you might have missed by other tools or means that you have in the network. For the third part of the presentation, didn't mention that at the beginning. Of course, you are most welcome to the expo area where we have a booth and a live demo of the system if you are interested to, well, basically just look at it, how the system is realized and what does it mean to look at the live actual data within the traffic. Any questions? Probably no.
I got a question regarding the personal data which you might capture out from the traffic. Can you also capture out by cognitive approach, say if personal data are transferred using PDF format or pictures?
As for PDF itself, we do capture PDFs. If they are readable PDFs, then yes, we capture their contents. They are indexed just the same as all the other documents. And based on this, doing full text searches in those data, we can capture, well, monitor them, raise alerts against them, etc. Of course, yeah. If that's a picture PDF, it goes the same as any other picture or audio file. I mean, we have the metadata, the name of the file, which usually is nothing, some figures and numbers and letters, and well, you can preview and see it, of course, and download, but like that, if that was the question. As for the contents, the system itself, well, the database allows to do advanced full text searches into any of this data. Besides, the system can enable an API, a documented API into this database that holds the collected data. So even more so, you can basically create even external applications or tools that will query the system to pull the data out of it for your own reports or anything. We have had integrations like this with some larger compliance systems where it's all about checkboxes and and tables to be filled out for ISO compliance, etc., etc. And the guys they integrated the NTSS simply to have kind of a background checks on, to be able to do background checks on what people are checking, checkboxes in their query forms, etc. All through the external applications from PHP code or anything.
Thank you.
Any other questions?
Hello. For example, I like listening music in YouTube, which is under HTTPS.
Yeah.
So is possible any exclusions, for example, or all my songs also will be collected by your
Well, by default, they
system?
will be collected, and especially if they go over HTTPS, you won't be able to preview them, even if you wanted to. But that's one of the things I think I mentioned at the beginning, and that's a thing that you basically must do once you have an installation and start collecting data. After a while, you have to look into this, and it's quite easy to pinpoint several sources of large amounts of data, like YouTube, like some company favorite internet radios or something that are better kept into exception lists, meaning that you can exclude those resources from being monitored. The same as you can exclude from monitoring your management team and whatever. Really up to the company policy on this one.
Okay, thank you.
All right, so no more questions. So I'll ask you to choose your favorite question from the auditors.
It looks like a tradition in this room to
Yes,
choose
it is.
the first question as favorite, because it's usually the hardest to raise. So yeah.
All right, so we'll give out to you as well invitation to our party. Congratulations. And again, let's thank ITSEC PALEJS for this presentation.
Mm-hmm.
Thank you. So now we have about 20-minute coffee break.